Very excited. Chop saw a while back. It's a relatively cheap chop saw. It does have a lot of range. There is a big problem with it, at least the one that shipped to me, and I will go over this in a minute. 10 inches blade size. The real specifications are over here, where it goes the max width of a crosscut, 12 inches for a 3.5 inch thick board, which is a very thick board, but it goes down considerably for a smaller stock, and when you're actually tipping and beveling the machine, there are certain limitations where you can't actually use an auxiliary fence with certain types of cuts. And you can see when the saw blade comes down, it's right in the middle of the groove roughly, which is perfect. And you can calibrate it and get some very square cuts out of it. I've managed to get pretty square cuts. The first problem is that the fence isn't actually straight though. This solid piece of metal, as it cooled, it warped and it didn't stay square. And I'm not sure there is a way to cool aluminum and have it stay square. You have to machine it after it's cooled, I believe, and the machining might heat it up. I don't know. I mean, I have no idea how to machine the aluminum properly. All I know is this fence isn't actually a straight line. But that's easily remedied with the auxiliary fence. So the main thing is to set the cut depth, because otherwise if you don't, by default it will cut all the way through. I have glued this block to the back, so that it does extend beyond the original fence, but it's still probably very possible to cut through it. I did place some tape to make up the difference between the fence and the auxiliary fence. So that helps. One thing I want to point out is one of the clamping positions is all but useless. Unless you have the clamp all the way over here, you're not going to be able to actually chop anything with the clamp in this clamping position. So it says it has 4 clamping positions, but this one isn't even over the table. So I really don't think you can use this clamping position. I mean, you can put this foot out, but using this clamping position is still probably not a very good idea. And I don't think there's any way you can lower it so that you can actually use it. So realistically, you can only clamp on this side. If you're trying to make any cut on the other side, you're going to have to learn how to saw left-handed. I mean, it's the only safe way to do it. The other thing is the laser. And I think the laser is actually capable of being calibrated so that it's accurate. The problem is that you can't move it to the left or right. And while you're adjusting it, it's going to randomly move left and right. Where I set it right now, I'm very happy with it. A 1/16 of an inch to the right of the actual cut. So as long as I account for that and move over a 1/16 of an inch, the best thing about the laser is actually to match up a random angle. So if you draw an angle on a piece of wood, you can use a laser to get your angle set on the table without measuring that angle. This is supposed to be square. If I set a square here and this is a square line, then you would expect, as you draw the saw forward, that it's going to stay in the same place in that groove. And what actually happens is the saw walks over to the left. Hopefully you can see that here. As you extend it, it's going to exaggerate the effect. So it's possibly fixed with 12 sheets of shim steel on the right side. You have to pick how you're calibrating it, because it makes a big difference if you're on the left or right edge of the line. I don't use these click notches, by the way. There's click notches, but as far as I'm concerned, they're all wrong. Start a little bit to the left of where you want it, and as you tighten it down, it moves a little bit to the right. And it should get you pretty close to where you want it to be locked into place. It seems that these two lines actually taper towards a point, so you can't rely on those. There's a secondary problem, that while it's tracking correctly now, it's just at the wrong angle while it's tracking. And the original problem is that it was just tracking at the wrong angle, but now it's tracking at the correct angle, but the blade itself is at the wrong angle. You can actually see it when you first make the cut. The farthest part of the board will have a taper like this, and then as you drag that through the rest of the board, you get a nice square cut the rest of the way on this side, whereas on the other side, the front of the blade starts to burn the wood as it goes through, and then on the far side of the cut you get a little taper this way on this side of the board. One could potentially put a shim in between here, but that's actually not the best place. The best place to put the shim is actually over here. So this is one cohesive unit, better to keep it together. If I remove the blade, I'll be able to access those screws. And what I've done is I've doubled this to be 8 sheets of shim steel here, and we've added 4 sheets of shim steel at the top. So you'll see how the cut was started and then where it tracked through, and you'll see where the cuts want to start, which is to the right of the position that it tracked through. So you can also tell just based on where it started where the blade wants to track, to the left, where it actually does. I think this is a step in the right direction, believe it or not. I know it looks bad, but it's actually better than it was. Install the safety now. I want to point out this is the blade lock. You can see on this face that we are getting even better on the initial position of the blade compared with where we were before. The initial position was even worse. We're not quite there yet. I'm happy to see there's no burning, at least now, on this side. It could just be because this is so thin that it bends out of the way. I need even more shims. That was 4, and that's 8. We might need 16.